Hello, Tigers. Today we're going to be working with simplifying radicals. Our I can statement for the day is I can simplify radicals. Simplifying a radical means to break up a radical into perfect squares. Our vocabulary is radical expressions, radicand. Radical expression is just what we're going to be working with today. The radicand is what's inside of the radical sign or square root bar. And then rationalize means to get rid of the radical in the denominator as much as possible. Again, we're going to be thinking perfect squares. Just a thought, just a reminder, when we're working with exponents, when the base is the same, then all you're going to do is add the exponents. So we have a 3 plus 3 is equal to a to the 6th power. Simplify each expression. So the first problem we have today is the square root of 125. So we want to think of numbers that are perfect squares that we can break 125 up into. And at the same time you're doing that, you want to put your perfect square up front. So 125 can be broken into the square root of 25 times the square root of 5. The square root of 25 is 5. So we have 5 times the radical of 5. For number 2, we have 3 times the square root of 80. And once again, we want to think perfect squares. So if I was thinking about perfect squares for 80, here's my thought process. I could do 1 and 80. I could do 2 and 40. I could do 4 times 10. Or I could do 5 times 16. So we want to pick out the one that has the largest perfect square. So for 80, 80 is going to break down into, let me just bring my 3 down with it, and then 80 is going to break down, the best or largest perfect square is going to be 16. I can find a perfect square in 4, but that's only 2. 16 I know will be 4 eventually. So we kind of use process of elimination to get there. We want to get there as quickly as we can. So 80 is going to be the square root of 16 times the square root of 5. Notice that I put the perfect square up front because I can break that down. So then I will do 3 times 4 times the square root of 5. Final answer, 12 times the square root of 5. Still simplifying, on this one we have the square root of 24. So 24 is going to break down into the square root of, if you're thinking we do 1 and 24, well, that's never going to get us there. 2 and 12, and what, 3 and 8, 4 and 6. So we want to find the one that has the largest square root. So that's going to be 4 and 6. So we have 24 is going to be the square root of 4 times the square root of 6. Negative 4 times 2 times the square root of 6. Negative 8 times the square root of 6. And there's our final answer. Moving on to number 4. Number 4, it may not be so obvious. You're going to think of your perfect squares. I'm going to show you the best way to do it, and then I want to show you a workaround in case you didn't get there immediately. So 108 can be divided into 36 and 3. That's the best way to get there because we know that 36 is a large perfect square. So we're going to have 2 times 6 times the radical of 3. So we'll have 12 times the square root of 3. Now let's say that you didn't recognize that right away. Let's say when you wanted to break this up, let's say you thought of 2, you got 108. Let's say you just broke it down into, let's say 54 and 2 instead. Well, the 54 could be broken down into 9 and 6, and I still have the radical of 2 here. So what can be combined then? 2 times 3, and then we have 6 times 2, which is 12, and then you'd have to break that down again. So 2 times 3 times 4 times 3. So we have what? 6 times 2 times 3. So no matter how you slice it, you end up with 12 times the radical of 3. All right, now you're going to see something a little different. You're going to start to see a radical in the denominator. Well, you cannot have a radical in the denominator, so we have to get rid of it. And so in order to do that, the first step is just to multiply by the radical. So the radical of 2, I'm just going to multiply by the radical of 2. So times the radical of 2. Whatever I do to the denominator, I'm also going to do to the numerator. So I want to take this thought for just a second. Bear with me, just kind of a side note. You can write yourself a side note. Let's say that I had the square root of 9 times the square root of 9. I'm just choosing a large perfect square. Not a large, I'm sorry, a small perfect square. So the square root of 9 is 3, and the square root of 9 is 3. And so the answer is when I multiply a square root by itself, then notice that I just get the same answer. So my point is that when I multiply the square root of 2 times the square root of 2, then what's left is just 2. So on the top, then I have 5 times the square root of 2, and I can't break that up any further. That's going to do it for us for that problem. On number 6, notice that I have a radical of 2 in the denominator, but I also have a radical of 6. So the easiest way to get here is to just divide the square root of 2 into 6. So I end up with 3 times the square root of 3. In other words, 6 divided by 2 is going to give me 3. Let's say I didn't recognize that. Let's say that I did the problem and I just thought, oh, I have to get rid of that square root of 2. So instead, I just multiply by the square root of 2, which, again, I'm going to do on the top, and I'm going to do that on the bottom. So I end up with 2 on the bottom. I end up with 3 times the square root of 12 on the top. Well, can 12 be broken down? Yes, 12 can be broken down into the square root of 4, square root of 3, again, thinking perfect squares, all over 2. So now I have 3 times 2, radical of 3, all over 2. So look what happens. That's going to cancel. All that's left is 3 times the square root of 2, which is exactly where we were to begin with, although our first choice was a much better way to get there. All right, got 2 more examples here. So number 7, we've got the radical of 12 on the denominator. The only way to get there is to multiply by the radical of 12, and I'm going to do that on the top and on the bottom. So what do I end up with here? 12, and then 3 times the radical of 12. The radical of 12, we just found out, can be broken up. You're always going to break it up the same way. 4 and 3, and then 12 here on the bottom. So what do I have? 3 times 2, radical of 3, all over 12. That's going to simplify. So I end up with, actually, I can do that a little easier. 3 times 2, all over 12. So it's 6 divided by 12, or 1/2. So I should end up with the radical of 3 over 2. Final answer. So in other words, 3, you could do it like this, paper and pencil, 1, 2. Just breaking it up because it's ultimately 6 over 12, which is just 1/2. All right, I want you to go ahead and try to do this one on your own, and when you are finished, then start up the video. Please, again, try to do it on your own. Welcome back, and here is your final answer. Check your work, and you should have 5 times the radical of 2. I hope that you enjoy your lesson on simplifying radicals.